This is part 3 for the 4th chapter, heat exchanger. So we're going to look on the effectiveness NTU method, which is the second method for the heat exchanging analysis. So the effectiveness NTU method is derived based on the effectiveness equation, which is given by the Q actual divided by Q max. Similar with the log mean temperature difference method, LMTD, we're still going to use the heat capacity, which is the heat capacity for the cold flow and hot flow is given by this equation, where throughout this you need to evaluate the heat capacity ratio. So the heat capacity ratio is given by the C minimum by C equal to C minimum divided by C maximum. So C minimum, you have to evaluate between the hot flow and cold flow. So the hot flow will become, the higher heat capacity will become C minimum, and the smaller C capacity will become C minimum. This is the equation for the effectiveness, which is given by the actual rate of the heat transfer divided by maximum possible of heat transfer. So the actual rate of heat transfer, you can evaluate whether for the hot flow or cold flow, which given by the heat capacity, which is the heat capacity is given by these equations. The maximum Q max is evaluated by the T max maximum, delta T maximum, which is it is evaluated based on the temperature difference of the heat in and C in. So however, two things cannot be happen simultaneously for the heat capacity, which is to evaluate for the Q maximum, which is C heat capacity for the cold flow cannot be equal to the heat capacity for the hot flow. But in case otherwise it happen, the fluid with the smaller heat capacity will experience the larger temperature change, and thus will be the first to experience the maximum temperature, at which point the heat transfer will become too hot. So the evaluation for the Q max is given by the C min times with the delta T maximum. So C min is either C for the hot flow or cold flow, which is which one is lower. So effectiveness NTU method, effectiveness is given by the Q actual divided by Q maximum, which is either can be this equation or you can use these equations. This is referring for the cold flow, this is referring for the hot flow. And then the effectiveness NTU, number of heat transfer unit, is a measure of the physical size. So which is actually effectiveness NTU method is more suitable for the design process. Then if you have the concentric tube, which is thermal resistance is inversely proportional to the overall heat transfer unit, so 1/U. So with this, the effectiveness NTU method procedure, you have to start by defining the heat capacity and the heat capacity ratio by evaluating the heat capacity ratio by evaluating the C minimum and the C maximum based from the CH and CC. And then you can determine the NTU, whether you want to determine the NTU or determine the effectiveness. So if the purpose of the problem is to define the NTU, then you have to know the effectiveness. But if the purpose to find the effectiveness, then you need to know the NTU, which means that the size or you want to have the effectiveness. Okay, so the effectiveness can be determined by using the chart, which is available in the textbook, or you can refer to the here, which is it can be used for the concentric tube for this one, or single tube and one shell multiple tube, which is this one, or 2 shells multi-tube, and as well cross flow, okay, for unmixed and mixed flow. Or you also can use the equation derived in table 11.4 to 11.5 that you can refer in your textbook. So you also can, finally you have to compute the rate of the heat transfer by using the equation Q equal to effectiveness times C mean TH in minus TC in, okay, which is this is a T max, Q max, yeah. So this is a Q max. And then you also can calculate the temperature for the inlet and outlet, and as well for other temperatures. So this is a guided example that you can follow throughout this tutorial. This is a guided tutorial that you can do some initial practice for concentric tube. Delta T1, delta T2 is available, and then you can evaluate which C minimum and C maximum based on the heat capacity for the hot fluid and cold fluid. So in here, it gives you the ratio for the capacity ratio 0.6, and then you need to define another parameters, which is the effectiveness. So the effectiveness is 0.82. That if you refer to the chart for the 0.82 and the heat capacity, this is a line for the heat capacity. So you can define the NTU. So the number NTU is 2.7, which is NTU is equal to AU divided by NTU is equal to ASU divided by C minimum. Okay. So AS can be defined from that equation, which is given you 9.03. So you can estimate the sizing for the concentric tube. So this is an assignment that you need to submit by 15th of May 2020, 5 p.m. So this is going to be counted in your carry mark here for your continuous assessment. And then finally, for the heat exchanger design considerations, in order for the design consideration, you need to understand to determine the rate of the heat transfer that required for that particular problem, and then what will be your budget, what will be your limitation cost, and then the requirement for the pumping power that will determine the sizing of the piping system that you're going to use. The size and weight, for example, if you want to design for a radiator, what will be the size for the compartment that you're going to be used. Type of the heat exchanger also will determine the size and the weight as well. You can refer to the compactness ratio. You just Google it, okay, compactness ratio, which is the volume divided by the area. And then finally, the material type that going to be used for the heat exchanger. Is it going to be type of the fluid, and then as well type for the heat exchanger itself, the tubing, the shell, and everything. So that also will determine the selection of the material will determine the size, the budget, the cost, and the overall perspective for the heat exchanger. So that's all for the heat exchanger section. So thank you very much, and then hopefully you're going to be continuously fine during this MCO movement control order. So hope to see you soon. Okay, so thank you very much.